On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we have example 4 of L'Hopital's rule, and we're going to be dealing with the infinity over infinity indeterminate form again. In example 3, we did the same indeterminate form, and I mentioned a shortcut back here, but I still did implement L'Hopital's rule to show you how we got that limit of 5 halves, even though we knew that from the beginning because of our shortcut rules earlier in Calculus 1. However, for example 4, we cannot apply that shortcut rule here since we do not have polynomial functions in our numerator and denominator. Therefore, let's try to find the limit of f of x. So f of x is this function, and we want x to approach pi over 2 from the left. Now, if you didn't have a graph for this, you would have to refresh your memory on some pre-calculus skills, but 1 plus the tangent of x, and the tangent of pi over 2 is undefined, but if we're getting close to pi over 2 from the left, this actually goes off to infinity. Same thing for secant of x. The secant of pi over 2 is undefined, but as you get close to pi over 2 from the left, secant of x also shoots off to infinity. To show that to you, check out these two functions. First of all, let's look at 1 plus the tangent of x. As we get close to pi over 2 from the left-hand side, notice this does shoot off to infinity, and the same thing applies to secant of x. As we get close to this x value of pi over 2, secant of x shoots off to infinity as well. Hence, when we try to do direct substitution here, we do get infinity over infinity. And when we have an indeterminate form of infinity over infinity, we can differentiate the numerator and denominator, and then we can try to find the limit again. So applying L'Hopital's rule, let's take the derivative of the top, 1 plus the tangent of x, the derivative of 1 is 0, the derivative of tangent of x is secant squared of x, over, now let's take the derivative of the denominator. The derivative of secant of x is secant of x tangent of x. Now before I go and try my direct substitution again, what I'm going to do here is simplify this so we can definitely get rid of one of these secants with the bottom. So canceling out a secant both in the numerator and denominator, we still have a secant of x up top, but all we have left at the bottom is tangent of x. Let's go and simplify this. Secant of x is 1 over the cosine of x. Tangent of x is the sine of x over the cosine of x. And now if we simplify this a little bit further, however you divide fractions is fine. I have a fraction divided by a fraction. I multiply by the reciprocal, so therefore we have 1 over the cosine of x. Change our division to multiplication, and let's flip this denominator. So we have cosine of x over the sine of x. Now we can cancel out these cosines. Therefore, our simplified piece that we're going to try direct substitution with is going to be the following. The limit as x approaches pi over 2 from the left of 1 over sine of x. When we simplified this trigonometric expression here, all of this, we get 1 over the sine of x. Now let's try direct substitution. Well, we don't have anything to plug in up top, so we have 1 over, what is the sine of pi over 2? The sine of pi over 2 is also 1, and 1 divided by 1 gives us a final answer, or our limit, of 1. Now let's verify this in Desmos. So here is that f of x function, and if we look, as x approaches pi over 2 from the left-hand side, notice what y value we're getting close to. We are getting close to a y value of 1. As you can see right there, we're really close to the x value of pi over 2, and that limit is getting really close to 1. That y value is getting close to 1. So yeah, this was a tricky example because right from the get-go, determining that we had an infinity over infinity form, pre-calculus skills, you don't use them a lot, especially when you're dealing with tangents and secants, I understand that. But realizing that we do have infinity over infinity when we try to plug in pi over 2 from the left-hand side, we're getting close to pi over 2 from the left. And then applying L'Hopital's rule, taking the derivative of the numerator and denominator, and then simplifying this thing down, we could finally try direct substitution here to get a limit of 1. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.